Давайте перейдем к самим презентациям. So let's start with the presentations. So now we will have a 40 minutes overview of the methods and approaches of explainable AI. The presenter is Tang Yui. She is a PhD student. And also Ma Ruimin, Loic Suingsu, and they are the master students of the St. Petersburg State University. I am their professor, but I hope you will not judge their presentations too hard. So let's give them the time, and maybe they will finish in 30 minutes. So we'll have some additional time. Yui, are you here?
Yes, yes, I'm here.
Can you start sharing the screen?
Yes, yes. Sorry, someone is shares. Oh, okay, okay.
Can you start?
Yes, yes, I can.
Okay.
Yes.
Не дергай, не дергай.
Okay, sorry, some problems. Okay. Can you see that?
Yes, yes, we can.
Yes,
We can see
Okay. Hello everyone, I'm Zhang Yi from St. Petersburg University. Today I will introduce to you a report called Overview of Methods and Approaches of Explainable AI. Firstly, I will give a brief introduction to the background of explainable AI to explain what is explainable AI and the meaning of it. Secondly, analyze the method and of explainable AI in detail, introduce the reasons for this method and the process of use, and then introduce development of XAI in the future. Finally, give a conclusion. Nowadays, we have so fast and widespread adoption of artificial intelligence in our daily life, which contributes to accelerating the shift towards a more smart society. But even with such huge advancements, a key difficulty to the use of systems with AI is that they often lack transparency. As human beings, we have too many questions about the results results of AI systems. For example, what did you do that? And why not something else? And so on. Actually, as shown in part A of the picture, black box nature of these systems allow powerful prediction, but the result rooster cannot be directly explained. This issue has triggered a new discussion in explainable AI. Part B shows us the principal process of explainable AI from output to input. The darker the red color is, the greater the impact on the result. So we can get the explanation. Image classified as rooster because of roosters, comb and wattles. And the case of cat is the same. It's worth note that in the third picture, the result of the AI system prediction is wrong. It is because of the existence of explainable AI that we can know that the reason for the mistakes is the copyright tag. And adjust the AI system based on this, we can improve its predictive ability. So what is explainable AI? Explainable AI is a research field that aims to make AI systems results more understandable to humans. This is a very important conceptual distinction that explainable AI make us to understand why the AI arrived at specific decisions, and definitely not to understand every single thing about the model, because it is very it's very impossible for complex AI systems. According to the scope of the interpretation object, explainability is divided into local and global. Local explanation mainly focus on the explanation of individual instance. On the contrary, the global tries to understand the model as a whole. Generally takes a group of instances to generate one or more explanation maps. Okay, before introducing the meaning of explainable AI, let's watch a video. The robot dog called Spot in this video. It is an AI product developed and designed by an American company. It will be used in industrial inspections and disaster rescue missions instead of humans in the future. But the technical accident that happened last year made people don't believe the safety of Spot. At the same time, happened last year. It reminds us that there are still many difficult problems in the field of explainable AI at present. And there are many similar cases. In this picture, when we add some noise to the panda picture, the system recognizes the panda as a gibbon, and a girl just put a sticker on the hat, and the system becomes unable to perform effective recognition. In short, to make AI systems safer, more stable, and more trustworthy by humans is the meaning of explainable AI. Next is methodology of explainable AI. There is a natural contradiction in the research field of explainable AI. It's the stronger explainability of the model, the lower its prediction accuracy, such as the decision tree model. On the contrary, a deep learning model with a strong prediction accuracy, but it's difficult to explain by itself. Based on this nature, explainable AI is divided into two usages: inherence and post-house. Inherence means that the model itself can be explained, such as decision tree, logistic regression. And the post-house generalized the explanation of the trained model by explaining the importance of features to apply to any model, especially deep learning models. Sorry. Now, these researchers reduced the conflict between explainability and the prediction accuracy in two ways. The first is improve the prediction accuracy of interpretable models. The second is develop more effective methods to explain models with high accuracy. Taking decision trees as an example. The accuracy of a single decision tree is very low, but when we put many decision trees together, its accuracy will be greatly improved. This method is called ensemble. There's no strong dependency between many decision trees. This method is called bagging. It's just like putting many decision trees model in a bag and letting them output prediction result through a voting. The other is that there are strong dependencies among many decision trees. This method is called boosting. Among them, the most representative example of bagging is the random forest model. For boosting is XGBoost. Both of these models have greatly improved the prediction accuracy of the tree models, but it should be known that at the same time, they have become black box model, which also means that we need a method to explain them. And next, I will introduce to you a first explainable AI method in this report. It's called SHARP. And I will show how to explain the XGBoost model with SHARP. SHAP is sharply additive explanation. SHAP is an additive explainable model inspired by Shapley value. Shapley value originated from cooperative game theory. Shapley distributes the benefits to each participant fairly through a reasonable calculation method. For each prediction sample, the model produces a prediction value, and the sharp value is the value assigned to each feature in the sample. Let's suppose the ith sample is xi, the jth features of ith sample is xij. The model predicts yi for the ith sample, and the baseline of the entire model is y base. Then sharp value obeys the following equation. Compared with traditional feature importance, the biggest advantage of sharp value is the sharp can reflect the influence of the features in each sample. And it also shows the positive and the negative of impact. Now, I want to show how to explain the XGBoost model by sharp. First, we take the this case, we take the influence factors of football player salaries as an example to establish a XGBoost model and explain it. First, we extract some features from the data that may have an impact on salary. But here is just an example. This feature may not be the best combination. These features are height, potential, and some professional index, and international reputation and age. Then we train the XGBoost regression model. In just like this, we set some parameters and we get our XGBoost models. And then in the process of explanation, first of all, we try to use the traditional feature importance to explain and visualize the results. From the results, we can only see that potential and international reputation have the greatest impact on salary, but we cannot know whether it is a positive or negative. At the same time, we cannot obtain the influence of each feature on the predicted value of each individual. Now, we try to use sharp to solve this problem. After successfully importing sharp, get the sharp value of each feature in the training side data, because there are 10,441 samples and 10 features in the data. The dimension of the sharp value is like this. Through a comparison, we can confirm that the baseline value is mean value of the fit value in the training site. They are same. This represented is the y base, and this is the mean of the date. And also we can randomly.
Okay. Sorry. When will you introduce the overview of different methods, like list of methods for XAI?
Yes, this I just explain what is the sharp and the application of sharp. It's very fast.
But
it's very fast.
Will you show the list of existing methods for XAI?
Yes, and after that, we have the another methods just like lame cam and grad cam, and so on.
Mm-hmm.
Is the same problem?
Okay. No problem.
Okay. And we can check the predictive value one of player salary and the influence of its feature on the predictive value. In this sample, we pick the 30th player in the data. It's just like this. And and this we know that sum of sharp value of each feature in the sample plus the baseline value should be equal to the predicted value of the sample. We can do the following verification, and it's the same. It's proof that we do it right. And Sharp also provide powerful data virtualization functions. The figure is a virtualization of the data frame above. Blue indicate that the contribution of the feature is negative, and red is positive. The longest red bar is the potential value, and the player's potential value is very high, and his worth also increases. The longest blue bar is age. This player is only 20 years old and have not yet reached the peak of his career. There are many uncertainties in the future, and his worth is threefold reduced. And in addition to virtualizing the sharp value of the single sample, it can also virtualize the overall feature. Each row in the figure is the feature. A point represents the sample. And in this picture, the age roughly shows distribution that the age of 24 to 31 years old is a boost to the worth of players. And the worth of player younger than 24 and older than 31 will be reduced by age. Next is develop more effective method to explain models with high accuracy. Neural networks are important to the development of artificial intelligence. Convolutional neural networks are widely used in various fields with extremely high accuracy. So it is necessary to develop methods for interpreting convolution neural networks. In this report, I will briefly explain the convolutional neural network and introduce three methods used to explain the convolutional neural network. They are KAME and Grand KAME and LAME. Deep learning CNN models to train and task. Each input image will pass it through a series of convolution layer with filters and pooling and connector layers. It's called FC and softmax. Convolutional is the first layer to extract feature for input image. Convolution preserves the relationship between pixel by learning image feature using small square of input data. And this is the process of the convolution. It is a mathematical operation that takes two inputs such as image matrix and a filter or called kernel. Consider is a 5x5 image matrix and a 3x3 filter matrix. And like this, by this computing, we can get the feature map. Convolution of the image where different filters can perform operations such as the edge detection and the blur or sharpen or another. And after convolution, image through ReLU function. ReLU's purpose is to introduce nonlinearity in our net. Since the real world data would want our net to learn would be non-negative linear values. Next is the pooling layer. Pooling layer section would reduce the number of parameters when the image are too large. In this case, we use max pooling method. This is currently the most commonly used pooling method. Max pooling takes the largest element from the feature map. The layer we call And the layer we call as a FC layer is fully connected. We flattened our matrix into vectors and feed it into a fully connected layer like a neural network. And this is the whole process of convolutional neural network. But note that the information in the fully connected layer and softmax is difficult for human to understand. It is also difficult to visualize. So in order for the CNN to give a reasonable explanation for its classification results, we can only focus on the last convolutional layer. Because for a deep convolution neural network, after multiple convolutions and pooling, its last convolution layer contains the richest space and the information. And the two method of explainable AI in this report is called CAM. CAM use the gap. The full name is the global average pooling. CAM use gap to replace the fully connected layer. Gap can be regarded as a special average pool layer, but its pool size is as large as the entire feature map. Through the gap, we can get average value of all pixels in each feature map. In our case, the model's training is already done, so we can directly start explain with computing the CAM. At the first step, we input a picture to the network and compute the network's classification outputs. And the next step, we input a picture to the next step. We get the weights connect to the importance neuron. Additionally, we save the output of the final convolution layer. Then we compute the CAM by multiplying each steps one of the final convolution layer outputs with the corresponding weight connect to the important neuron. So in this picture is a W1 multi with depth 1 of final convolution layer output and so on. And finally, sum them up and we will get the explainable results of explainable. on this heat map, the dog position is accurately displayed in this and original in this. CAM's interpretation effect is very good, but it has a serious shortcoming. CAM needs to replace the fully connected layer and softmax with gap. It means that change the structure of the original model, which leads to need to retrain the model. But after CNN model is applied or when the cost is very high, it is impossible to retrain the model for CAM. So the serious disadvantage of CAM is that the scope of use is limited. In order to now change the structure of the model, the researchers developed the grad CAM method based on CAM. And this three method of explainable AI in this report is called a grad CAM. The structure of the CNN is not changed, and the value is added to the final weighted sum. The basic idea of grand CAM is the same with the CAM. The overall structure is shown in this picture, and they have two differences from CAM. One is structure is not be changed, and two is they have a ReLU function. The reason for adding RELU function is to only focus on those pixels that have position impact on a specific category. If the RELU layer is not added, some pixels belonging to other categories may be brought in eventually. 3, by affecting the interpretation effect. The effect of using GrandCam is interpreted a classification result is shown in picture. In addition to directly generating heat map to interpret the classification results, GrandCam can also be combined with other classical model interpretation models, such as guided back propagation, to obtain more detailed explanations. The advantages of GrandCam are not limited to the interpretation of image classification, as long as CNN is used. Any deep learning task related to image can be explained by GrandCam. But CAM and GrandCam have common limitations. CAM and GrandCam are only useful for models with known structures, especially for CNN models, which have a good interpretation effect, but they cannot be used to explain unknown models. Here is another method. It's called LAME, which is the last method in this report. Even if you don't know anything about the models, you can explain it by LAME. The red and the blue areas in this complex classification model. It's a black box model. The bold red cross in the picture is instance be explained. It is difficult to approximate and fit it with the interpretable model from the global scope. But when we put the from global to local, we can set some parts can fit it with linear models. Specifically, sampling from around the bold red crosses. This process is called perturbation of features. Next, classify the sample with a classification model and get the results. In this picture, it's these red crosses and the blue dots. At the same time, white is assigned based on the distance between the sample and the bold red crosses. White is the distance between them, just like this is distance is white, and at the same time, white is assigned based on this. And the dashed line is the locally interpretable model learned from these samples. The classification result can be explained based on this local interpretable model. When LAME is applied to a picture recognition, the perturbation of the features required by LAME will happen at each pixel of the picture, which will result in a very large number of features. So using LAME for picture task requires some special skills, namely superpixels. Superpixel refers to an irregular pixel block with effective information formed by neighbor pixels with similar texture, color, brightness, and other features. In fact, instead of using single pixel as a feature, but using a superpixel as a feature, the feature space of the entire picture is much smaller and the sampling process is much simpler. After that, we give some perturbation to the picture. In other words, it's randomly remove some superpixel parts, and then it's just like this. It have many situations, and then we calculate the probability of each situations and weighted them. And finally, we can get the result of explanation in this picture. We can see the lame recognize, lame explain, the model recognize this picture have dog is like this, and explain the cat like this. In addition to interpreting the classification results of image, LIM can also be applied to tasks related to natural language processing. Because the LIM model is a model agnostic, it has a wide applicability. Next is development of XAI in the future. In the research field of explainable AI, a lot of research have focused in model agnostic post-host explainability algorithms due to their easier integration and a wider reach. Additionally, there is a large interest in addition and local surrogate models using superpixels of information to evaluate the input feature attributions. A new trend is using concepts as explanation are gaining traction. However, evaluating this method are still a challenge and pose open question in XAI research. In this report, I introduced what is explainable AI and the meaning of explainable AI, and introduced 4 explainable AI methods, namely SHARP, CAM, GrandCAM, and LIM. And finally, summarize the challenges and develop trends of explainable AI. And thank you for watching.
Yui, thank you very much. That was very interesting presentation.
I have a question.
Yeah.
Okay.
So at the beginning, this sharp method, yes? Why use only Shapley value? There are also other values. So you can use Tice value. And did you consider other possibilities? So how can you be sure that Shapley value approach is the best? There are other values also.
About this question, actually, I just read many papers about explainable AI, about game series, just have SHARP method now be used in the research of explainable AI. But about another values, I just
I think you can think about this. You can get some new results if you think about
it. Maybe, but okay.
I can comment on this. So, well, why Shapley value is used widely? Well, I can tell that SHAP is only one direction of explainable AI. Actually, I think Yui wanted first to present the list of all methods. And SHAP is the method of 2017. So it is not like the cutting edge method currently in explainable AI, but I think it was the most related method for our research direction and for our seminar. And well, why Shapley value? Because this is the most well-known cooperative solution.
but there are many others also.
Yes, and for the specialist in
I think you can think about it.
Yes, for specialists in artificial intelligence, the easiest solution was to take the most widely used one. And I can say that they actually transform the Shapley value in the way that we don't have formula of Shapley value on the slide, right? Or we have? Do we have formula or not?
Unfortunately, no formula here.
Yes.
Only picture.
No
I
problem.
don't know this problem.
So in the Shapley, they use not the classical formula of the Shapley value, but as far as I understand, they use for the probability part, they used not a probability of the form of the coalition S, but they use a uniform, a kind of uniform probability. So they do not think that each coalition has a very specific probability to be formed. No, they say that each coalition can be formed with any probability, with some equal probability. But why they are interested in SHAP? Because SHAP is based on this additive, is based on the is based on the value of the characteristic function with player I and without player I. So that
there are other approaches also like this. So you have to look on something else.
yes,
Definitely.
yes,
Yes. In future, yeah.
Yes, definitely. We should do this. I just wanted to comment why they were interested.
Yes.
Yui, could you please say a few words about how the SHAP approach is applied? Because I'm not very clear that all of the participants understood this part. So it's a key point, like how it is applied. So I think if you could somehow connect now game theory with the artificial intelligence here in this SHAP approach, that would be very good.
Okay, SHAP.
Few words, yes, few words of how SHAP is applied. Because next presentation is actually about the SHAP.
Okay. I will. Sorry. In this Shapley structure, yes, not. Not have the structure of Shapley.
No need structure of Shapley. Maybe you could say such as things like this. So we have cooperative. So I can say a few words. So the SHAP approach is based on the model of the Shapley value. And what is actually done is that we try to explain the individual contribution of each feature in the data that comes into the AI system as input data by using a Shapley value. So we try to change the structure of the input data to go inside of our artificial intelligence model, then and calculate the characteristic function, and then we calculate the Shapley value. But well, from this presentation, maybe it's a little bit hard to understand. But the idea.
Okay, I understand. Maybe others don't understand. Yes.
Okay. That's good.
In future, it will be better to fix attention on this mathematical background. You see? Yes.
Yes. I totally agree. Yes. Okay, Yui, thank you very much. That was a great presentation. I think maybe even next month we can extend it, add some like list of all approaches and things like this, add some more details. So thank you very much. Thank you very much. I will help you with this. So the next, let me share a screen for a second. The next presentation is the presentation of approaches for high dimension explainable AI. The presenter is the Totsein. He's a PhD student, and also it's a joint work with Sufeiran. He's a bachelor student, and I'm their professor. So before we start, team, maybe you could start sharing the screen. I will say a few words why high dimensional explainable AI is important, why we have chosen this topic. So actually nowadays in artificial intelligence, high dimensional is very important. Like a curse of, maybe I think you have heard something about the curse of dimensionality, is when the scale of the problem is so big that actually your computing, the system that you use for the computing cannot carry out, or cannot give you the result. So actually in here we have the same problem. If we have a high dimensional data as an input data for AI system, then after that, when we try to explain the solution of this system, and we use the methods such as SHAP or Shapley value based methods, then we have a problem with dimension. So big dimension of input data means a big number of features, means big number of players, because one player is one feature. But it's very hard to calculate the Shapley value for the big number of players, because we do not only calculate Shapley value, we also run our AI system for each coalition to calculate the Shapley value. So this kind of procedure takes a lot of time. So we need special approaches. And this presentation will be about this direction, about several solutions, but also there are alternative methods. Maybe next month we will compare our solution with the alternative solutions. So sorry, Tsin, sorry, could you please start? I have some. Maybe I took your time a little bit.
Okay, no problem.
Could you please turn on the webcam? Do you have webcam or no?
Yes, I have webcam, but some problem with the device. So if I open it, it will be problem with internet.
Okay,
And,
okay, no,
sorry.
No problem. Yes, thank you very much. Thank you.
Okay, I start. And my name is Zhou Jingying. I'm PhD student of Avanes Petrosian. And in this work, in this month, we try to solving the high dimension problems. And here you could see an outline. First, I will introduce about our pipeline and our solutions for high dimension problem. And in our solution, all of them based on Shapley approach. And actually, this topic we just talked, and for Shapley value, why we using Shapley value? Because that in cooperative game theory, Shapley value used to solving the problem of imputation in somehow a higher imputation means that a higher contribution. So we think that Shapley value is very suitable for us to explain the machine learning results, to show clients how different features in input dataset contributed to the results. That's why we all of our research currently based on Shapley approach. Of course, in future we will continue on this path to exploring other indicators to measure the contribution. And for our for our currently process, we using isolation first, and we have two solutions to solving high dimension problem. First is bi-level approach, and inside bi-level approach, we using also some special clustering methods which called constraint size k-mean clustering, and also sampling methods as second solution. In final, I will introduce the simulation results and conclusion. So here you could see the pipeline, and high dimensional cancer data as input, and we take input into the anomaly detection algorithms, and after it we need to approach bi-level approach and the sampling approach to help us to obtain the Shapley value. The reason we propose such two solutions is that one, the input data set is consists of too much features, the dimension is too high, it will lead to a problem of incalculable for Shapley value. And here you could see the dataset links. If you're interested, you could access it. This is from the Skyline database. Okay, this is the.
Could you please go back to the previous slide?
Yes, yes.
I will. Sometimes I will just add some comments. So, what is the purpose of this work? So we have a automatic system, AI system for anomaly detection, which is called an isolation forest. Isolation forest now is a kind of state-of-art method. So it's not the best, not the worst method, but easy to use and very widely used method for anomaly detection. When we applied anomaly detection to cancer data, means that we want to find who who is the one who with the highest probability has a cancer. So we study data about several I'm sorry, my English is not enough for this. So the hospital clients, and we have like a wide range of information about them. Currently, we have maybe 30 features, 30 types of information about the well, about their illness or something like this. So, and then we try to, using the system, we try automatically to find who has the cancer. But the problem in this kind of systems is that, well, even if we receive this result, it's called the prediction. If we receive this prediction, we should understand why we receive this prediction. The doctor should look and understand which feature gives us this prediction. Why exactly the system thinks that the patient has a cancer. And the problem is that the data is of a big dimension. 30 is already a big dimension for us. 100 later, we will, maybe 1 month we'll present the results for 100. Again, it's a problem of a dimension. So in this presentation, we'll try to solve this. Okay, sorry, team, please continue. Please continue.
Okay, no problem. And here you could see equation for Shapley value, and the key parts to obtain Shapley value is to calculate the characteristic function for all the collisions. And as I said, that for some training data set, the feature is too much, it means the player is too much. So it's almost impossible to calculate all characteristic functions. So that's why we propose 2 solutions to solving this problem. And this is the process to obtain the Shapley value on algorithm AI. So first step, we need to define players. And usually in AI, and the input data will consist of several features. And in this case, we consider the feature as players. And then we need to generating all the possible collisions. And the third step is to run AI algorithm to obtain the characteristic functions for each collisions. And usually for anomaly detection system, we defined prediction accuracy as characteristic functions. And then we repeated step 2 to 4. Then we could obtain all characteristic function. Finally, we could using the equation of Shapley value to obtain the to calculate the contribution for different features. Okay, in this project, we based on isolation forest. Here you could see the properties of isolation forest. First is subsampling. Second is sampling. Swamping refers to a problem that normally data set is quite similar like anomaly. And the third is masking. Masking refers to the data set which consists too much anomaly, and the density of anomaly is so centered. And the fourth is about high dimensional data set. And the last one is about normal instance only. So actually all of these properties means that it happens in all AI algorithms, because when we obtain the data set from reality, we couldn't guarantee that the data set is good enough for the model. So this is also one purpose why we choosing isolation forest. Because isolation forest could handle the problem of the high dimension, and even on the data set consists of all normal instance, it is also okay to train and to do some prediction. And in the bottom, you also could see the reference from the papers and the projects. Okay, first solution we propose to solving high dimension is, we call it as bi-level approach with constrained size clustering. From the picture, you could see that we have a lot of players, and the players, as we defined, it is the feature of input data set. And trying to reduce dimension, first step, we're trying to do a clustering. And actually in clustering, we already tried several methods, for example, aggregative clustering and some others. All of them has a problem that after clustering, the size inside of clusters also a big problems. So that's why we find some special methods. It's called constraint size. It means that we could set the size for each groups, so that in this way we could guarantee all of the groups will have a good size for the shop to obtain the Shapley value. And the algorithm we used for clustering is called k-means constraint. And here also I attach two reference papers and the projects. Okay, so here we could see that we defined the process into two levels. First level is about the group level. So we could obtain the phi-t on the group level to obtain the contribution of each groups. And second level, we will enter the groups to obtain the players inside of the groups. And third step, we multiply the phi-t and the phi-s, both on the group level and the player level, so that we could obtain finally Shapley value for each features in the game.
1 second, Etienne, could you please go back? So I want to comment on the slide. So what you can see on the right, the bi-level approach is actually, the idea comes from the cooperative, not even for cooperative game theory, from the game theory with like a multi-level game theory, where we have, or coalitional game theory, where we have a group of agents n, and then and this group of agents is divided to several coalitions, and then we decide how to share the joint payoff. So we first we decide how to share inside of each coalition, and then we decide how to share the overall payoff between the coalitions. So it's kind of multi-level approach. And but in our case, actually, the second level you see on the slide, obtain phi for each sequence inside of the fixed group. It's a mistake, not fixed sequence. It means for each player. We do not have sequences here. So we what we do is we try to separate our data set with 30 features into several clusters of features. And then we calculate characteristic function and Shapley value for each cluster. And also then we consider each of this cluster as a one player. And then we calculate Shapley value for all of these clusters. And then by multiplying these two Shapley values, we obtain the Shapley value for each unique feature. Of course, you can think that when we are doing this, we are losing some of the explanation of the value. So you can consider.
Sorry, only 3 minutes left.
So sorry, it's very important. Sorry, I'm very shortly. So how to measure the effectiveness of this approach? We should compare the Shapley value for the whole game where we just take 30 features, and for each of these features we calculate Shapley value with the results of the Shapley value for bilevel method. Because bilevel method is the aim of bilevel method is to reduce the computational complexity, not to use bilevel method itself. Yes. So when we were trying to define how to do bilevel method, how to do clustering, our aim was to try to divide these features in the cancer data in order to not to lose the accuracy of explain. This means that we had to divide this cancer data into cluster by the physical meaning of these features. And since we had a lot of instance of data, then we considered each feature as a time series. We could not share this on the PPT, we didn't have enough time. But actually each patient is a kind of time instant. So we use some metrics such as we use things as a Fourier transform and wavelet transform to define metric and to define the distance between each feature. Then we used constraint size clustering to divide features into several clusters, but so that the size of each cluster is equal to each other. You will see that in a little bit later, because we don't want imbalanced size clustering. We want balanced, and we want clusters that would be not connected by the physical meaning. Okay, so please, Tine, could you please continue? Sorry.
Okay. Sorry, time is limited, and here you could see the simulation result in bilevel. So our test data set is from Skylearn database, and then the size is 30 multiple 500, and we set net clustering number as 5, and the size for each clustering is about 5 to 6. And the approach we used is called constraint k-means. And left picture shows the group levels. You could see the net different groups do different contribution to the results. And the right picture shows the results in group 1. We just find one of them to show you could see that the all features located inside group 1. That has different features, and we automatically cluster them by distance using constraint k-means. And after it, we do certain steps. We multiple two results, group 1, multiple each, and then we could observe all the features contribution to the results.
Etienne, could you please go back to the previous slide?
Yeah.
Actually, I want you to understand. So when we consider a cancer data set, you can see the parameters such as mean concavity, Wars concave on the right-hand side, picture, Wars compactness, Wars concave points, and so on. All these are a kind of connected parameters of the not of the illness, but on the these are the parameters of the cancer, but we do not know whether this cancer is dangerous for a person or not. Yeah, so we study these parameters, and you can see that these parameters, they come into the one group, not by a chance, but by the physical meaning. Yes. Okay. Tin, could you please go to the next slide? Can you please zoom in and maybe you could comment on which features come into one cluster or not, because we cannot see. You see, now all features are, they are not in one cluster. So if you know.
This part also need checked by content from picture. I also had to identify which feature in which groups.
Okay, so it's no problem. Actually, what I can see is that, for example, features. Let me. So I think these features come into one group because of the value of the Shapley value in here. These are as well. But of course, maybe next month we will present more, or if you're interested, we could tell you a little more about it. Okay, thank you.
Okay, and also for second solution we proposed to solving high dimension is about the sampling methods, and the idea is come from the paper polynomial calculation of the Shapley value based on sampling. And the left, you could see the algorithm, right? You could see the process. Actually, for this part, it's not much to explain because everything seems quite clearly. And we just, for example, we could using, according to the probability, we generating the procedure pi, and under the study Shapley value, then we could obtain the characteristic function by iteration ways, and then after we summary for m samples, then we do a division, and we could obtain a estimation for the Shapley value. And here it is the results from the simulation of the sampling. And actually, I compared the two figures, and now for currently process, it's hard to measure them, to compare them. And I think the next step for us is that we will continue to do some analyzing for the results. And also for sampling, here is the converging diagram. And Y, it is the mean squared errors, X is the sampling size, and each sampling size will consuming for 30 iterations. So it means using sampling, we could get a convergence in about 300 or to 600 iterations. It's quite fast compared with original solution. Okay, so here is the conclusion. So briefly, we propose two solutions to solving the problem, not solving, but we could explain results in high dimension. When the players too much lead a problem of incalculable. And also we compared the time performance. We found that bi-level approach is more faster than sampling. But in the other hand, sampling approach actually is more easy to apply in different applications, because for bi-level we need to considering the business. We need to consider the data set, consider the different features, and the relationship of the features. Even for the measurement to the features is also not easy, I think. And also we have some challenges and future work. First is that incalculable dimension for Shapley value will lead no comparable problems. It means that in this, it's hard for us to obtain the Shapley value with original solution. And so it's hard to comparable which results is better, which result has more close to the real solution. So this is one work we need to do. And second is now currently even in the industry, there is not any indicator to measure the explaining results to tell clients it is good explaining or not. And I think here we also need to add a set to consider other values not instead of Shapley value, or just analyzing if the Shapley value is most suitable to as a measurement to the contribution. Okay, sorry, the time is limited, so I speak so quickly. And that's all for my presentation.
Okay, thank you very much.
Thank you.
It's not a problem. But I think we managed to explain everything, almost everything. Also, I wanted to comment that actually the bi-level method in game theory was introduced, I think, in the works of Professor Leon Petrosyan and his PhD student